You should already have these on your vocab sheet. So your vocab sheet should be filled out all the way, hopefully. So these shouldn't be new. But hopefully it has something along the lines of these. Center of rotation is the point which the object or design is turned or rotated. So obviously with your project, guys, you're all starting with a center of rotation. You're building off of that center so that you can have rotational symmetry. Okay, that's where you're rotating from. A kind of interesting one in terms of the back there's the one that was like, is supposed to be a bunch of iPads. So they had a center of rotation, but the actually spots that land on each other was actually the outside. There really was no inside. So you can have like a separate drawing. Like for example, if you, let's just make something up here. If I say this is my center of rotation, and then I just put a star here, a star here, a star, whatever, like all the way around so that they can rotate evenly all the way around. I don't really necessarily have to have a design in here. This can be empty. And I can have my center of rotation be by itself and then have my actual design rotate on the outside of it. That's still a rotational symmetry. Okay, so the point is your center of rotation is the center of your design or where you're rotating your design around. Does that make sense? Okay. Rotate, I just pretty much said this. When a shape can be turned about its center so it can rotate onto itself cleanly is more than once in one complete turn. What that means is, like the BMW sign, okay, since these were shaded here, this only has 2, but that still counts as like it landed on itself once and then back to the beginning, so it does have rotational symmetry. Okay, but remember the ones that didn't were stuff like the Cadillac because it had pieces were missing and the colors didn't match up, so it couldn't. It does not count for rotational symmetry. This is the important part. It does not count for rotational symmetry by going all the way around once. That doesn't mean anything. Just like dividing by 1 doesn't mean anything, right? Okay, so just keep that in mind. All right? Okay, for each shape, state the order of rotation and the angle of rotation. Okay, write the angle of rotation in degrees as a fraction of revolution. So, order of rotation of this is what? 2, correct. It's 2. You know it's 2 because it's a rectangle. Can't be 4 because it's not a square. Square is 4 even sides, rectangle's not. These match, so I can flip this once and then back to the stop. So it's an order of 2. I don't know why I'm writing highlighter, but I kind of like it. Okay, order of 2. And then what's that degree? To figure that out, you go 360 divided by 2. 180 degrees, and then back to the start. You don't have to write 360. I'm just showing you. Right. And the fraction of the revolution, as Nolan just said, is 1/2. Okay, how about the pentagon? Order of 5, good. So then you'd have 1/5. Every 1/5 turn, it's going to land on itself, which 360 divided by 5 is, what is that? 72? I believe you. Okay, 72 degrees. So every 72 degrees, it's going to rotate and land on itself. Well, let's just think about what that means. Okay. Here's what 90 degrees is. So roughly about every rotation about this much is going to land on itself. That's what this distance is right here. See how it's just a little bit less than 90? So that's when that's the next, this corner rotating to there is 72 degrees.
I think it makes you the exact same.
Yeah. Yeah, and this, my projector's a little bit oblong, so it doesn't look perfectly, but your paper looks a lot better than mine. But yeah, it's a regular pentagon, so all the sides are equal. Okay, how about this here? This is a kite, right? You guys know what a kite is? What's your order on that one? Yeah, so if I turn this, if I put this corner down here, the long side's going to be over here, so this one has none. Yeah, it's no rotational symmetry. Right. Yeah, it does have line symmetry, Brett. Okay, it does have line symmetry, but we're not asking for line. Does that make sense visually? All right. Okay, let's keep going here. All right, so here's this chart here real quick, show you know. So this one here is a rotation symmetry of 2 or 1/2. So 360 divided by 2 would be 180. One turn order of rotation is 2, 1 over 2. So this, your guys' order of rotation is 2. Okay, this one again I think is 0, isn't it? Yeah. So this would be none. Okay, how about the triangle? Yeah, it's 3. One-third. Good. So they are saying, excuse me, let's just make one adjustment, even though it doesn't mean anything different, guys. They are calling this a 1 for order. Like, it's only on itself, not 0. Sorry, that's not technically right, but the degree of rotation is 0 or 360, okay? And then has no rotational symmetry because it doesn't have anything bigger than 1. So we're still good there, but we call it 1, not 0 is the only difference. My apologies. Okay, and then example 2. So if we look at these, we're going to fill out this chart. The pictures are down here, so I'm just going to go ahead and go up so we can see the complete chart for mine. Okay, so it just says complete the chart in each figure. So figure 1, the rotation has rotational symmetry. Why doesn't it have line symmetry? The arrows, yeah, the arrows. So if I draw a line here, if I fold this, there's no arrow that's right next to this. If I go here, I mean, anywhere I go, the arrows aren't going to mesh right perfectly on each other with line symmetry. However, they will rotate, right, and land on each other. So that's just rotational symmetry. Remember those pictures over there I pointed out to you yesterday? The ones that have curvature or have any type of bend in them are not symmetrical in terms of lines. You guys listen to me? Whenever you start putting curves into things, curves work fine with rotating, but in terms of lines, curves don't work well. Okay? So these having kind of a curvature to them, that makes it hard to have line symmetry. So these have no line symmetry, okay? But that does have an order of 3, which is the 120. So this one has just line symmetry, and then how many? Yeah, it looks like just 1 to me. So vertical. Order rotation's 1, which we really don't care about. That's just 360. That's really nothing to us. Okay, that's really nothing to us. So you can put order of 1, but that does not mean it has rotational symmetry, because then everything has rotational symmetry, right? Okay, numbers of lines of symmetry. So look at this figure here. It has the combination. It has both. It has rotational and linear. So number of lines is 2. It has vertical and horizontal. The order is 2, so it can flip directly on top of itself, which gives you 180 degree for rotational symmetry. Okay, what shape is used to make each design? How is each design made? So in these right here, what shapes used to make these designs? Well, a triangle is used to make this one. Okay, circles is used to make this one, and then hexagons is used to make this one. These two are examples of translations. So what that means is the same size circle moved over, same size circle moved down to the left, down to the right, down to the right. So it's just translations of the same image used again. This wasn't really translated, this was actually turned. Because the reason it's not translation is because if I move this down to the left, notice that that arrow is going to be pointing down here. So this is not a translation. Okay, this is a translation. over to the right, down to the left, over to the left. Like that's all the same shape, same image. Okay? So translation is taking, just think about taking a desk. I'm translating this desk to here. It's the same desk in a different spot. These are actually different positions. I didn't rotate the desk. Okay? So that's the difference between translation and rotation. Yeah. Right, the arrows are being rotated, correct. They're not being translated. Okay, good. And then reflection. So reflection is these circles are reflected, right? But these arrows aren't reflected. Excuse me, because I can't reflect this arrow to land on another arrow because they were rotated. Are these reflected? Yes, they're reflected all four pieces. Okay? Questions on those three differences? So you got translation, reflection, and rotation. No, that's good. Do anything? You good? Okay, all right. Let's go here. All right, last piece. So look at each figure. Circle the type of symmetry for each figure. Okay, so looking at this figure here, does this have rotational symmetry? Sure.
Yeah.
Does it have line symmetry?
Yeah.
So then it has both, correct?
Yeah.
This one's both. I have line, and I can go one rotation of 180. You guys good with that? How about figure B?
That's a hard one.
Yeah, it's tricky, isn't it? So let's look at it here. So think about where you could draw a line. Now here's the problem with the line. I can see right at the bat, these two are different heights. Yeah, so there's no line symmetry. It looks like it's just rotational. It is rotational because if I rotate this, this will be, see how this is a little bit to the right? That's a little bit down. Boom, boom, boom. Those will land there. So yes, it's just rotation symmetry. Okay. So figure A, draw line symmetry. I did have them. I erased them. Sorry. There's one. There's two. Okay. What's the order of rotation in figure A? 2. Figure B? 4. Good. 1, 2, 3, 4. How can you make each design using part of a figure translations, reflections, or rotation? So how can I make, okay, we'll just say it out loud. You can write it in here. How can I make figure A a translation? Yeah, I just take this image. I just move this image down to the right. The same exact image. I translated it. Okay, same thing here. For reflection, this one is reflection because it has lines of symmetry, so it already has reflection, but I also could, I could reflect, I could draw this line here. I could draw a line right here, and I could reflect this over that line. Or I could reflect it over here. Flip it over, right? Okay. Here, same thing. I could reflect it over here, that same image. Reflect it over there. And then rotation, I could rotate it, or I can rotate it within like the center of, with the center where it's at. Same thing here. I could actually rotate it over the reflection lines as well. Okay. All right. So one time, I know we're a little bit jumbled there at the end. Yep. Sorry. Cool. Translations is moving the same image, the same size. Reflection is jumping over a line, X or Y axis, or even the origin. And we'll talk about the origin later. And then rotation is rotating it around a center of rotation. Okay.